Hi guys, taking a break from the normal routine of looking at different models, testing out different things. Today, since this is Sunday today, so I decided to do a fun experiment and try to build the idea, and I want you to contribute to this project as well. So the TLDR of my thought process is that I know how to query a single database, a single table. I know how to query that and get the output. I know how to query a database, let's say, which has 5 to 6 tables. That is pretty easy. But how about a database that has hundreds of tables? Let's say thousands of tables. So what is the best approach, and how do we integrate it into a RAG system so as to get, or even better, do we really need a RAG system for that, or is there any other system that will work? So essentially, we have team managers in any organization. They would like to know more detail about the database they have, the data they have. Now, they are not sometimes well versed, but sometimes not well versed with the formation of, construction of SQL interfaces, SQL queries. It's difficult for them to get that data out. You may come as the engineer level and the middle level to find solutions for that. But again, it's difficult to get their understanding of what output they want, go to the database, send the query and get the required output. That's a very long drawn process. So instead, what if we have a UI system here where the users are going to ask questions in a natural format, a natural language. Give me the sales for the last 2 months for the particular user. Now, that's a simple question, but this UI will send that to the agent, let's say our agent, and this agent is going to talk with our SQL database, which has hundreds of tables, and give you the particular response. Now, if you have worked with an agent, a system like this, you know that it is pretty difficult to get a good SQL query. It's pretty difficult to get the desired response. It works, although in the many GitHub, many repos and solutions that you see, it will work for 5 to 6 tables. But if you have a real use case, a real database which has hundreds of tables, this never works. But what I was thinking, and I would like you to be a part of the thought process as well, with the help of the comments that you will put in the comment section. What idea that I've been thinking is, and I do have one case for this particular organization that I worked with where I had sort of implemented this, but this is the first time I'm trying to explain this and trying to bring this idea out. And it's not a new idea. It's simple. With the advent of LLMs, we just need to integrate the different pieces that are available. The technology is available in different pieces, in bits and bytes, and it's our job as a prompt engineer to mix those bits and bytes and get the system running and sell our service. So the first argument that I would like to put forward is the LLMs. So the LLMs are, since they understand a natural language query, so we are going to give them the same. So there will be no treatment, or there will be no inputs. We won't create a query to be put into the SQL database. So the LLM should be able to make its own SQL query. That is one requirement. Another obstacle that we have is the context length limitation. The context size is very limited. Let's say we have a context size of 6,000 tokens, or 6K, or 8,000 tokens. That is the context size. We cannot fit in when we create the prompt, we need to input so many things. The first is the system prompt. You are a chatbot. System prompt. You are a chatbot. You have to reply so and so. And the query itself. You're putting the query of the user itself, and then you need to put the data. So there is no place within this context window. There is no place to put all the data if the tables are huge in number. So essentially what a table will have is columns, and the data will be filled in real time. Okay, so one argument, the tables names of the tables and the column names for each of the tables will be fixed. That is for sure. And for considering a particular period of time, let's say, it doesn't change at every moment of time, which is very different for the case of data that is coming in, because there's SQL databases, there will be addition of data, deletion of data. So this proves my point that we cannot implement a RAG system for all these database, for all the tables along with the data. RAG is not possible. It will take so much time, because every little change will trigger the formation of the RAG, or formation of a new embedding, and the storage of the new embedding. That is very difficult. So that step is clear. We are not going to implement RAG for all your database. Now, moving forward, and very quickly, what proposal do I have in mind is, let's say I will talk about 100 tables in the beginning. Let's say we have 100 tables, and each of these tables are updating in real time. Each of these tables has different columns, and rows are the data that has been updating. Now, for an SQL database, the names of the tables are unique and fixed. So let's say we have table A, table B, table C, and so on and so forth. We have hundreds of tables. Each table, if I just zoom it, each table has different columns, and the names of the columns are fixed as well. Let's say A1, A2, A3, A4, A5, A6. So what we can do is, first of all, the idea is step one, if I write step one, the idea of step one is we take the names of the columns. So let's say I talk about a JSON file where there are key value pairs. So let's say the table A has a description of the table, just a description, a brief description. Then the next line can have B, and this is just a description of table B. It's a natural language description, which could be prepared by the LLM itself beforehand, but this is the step one, is something which we can do beforehand for our database. So we will have 100 tables, and these are the 100 tables along with the descriptions. Now, I believe that with 100 of tables, this should be possible to be integrated into a RAG system. Okay, if not RAG, we'll look at other solutions, but this is my proposal of putting in the 100 tables along with the description into a RAG system. Okay, next step, what I'm thinking is, when the user comes up with a question, that question is sent to an agent, and the name of that agent, let's say it's a table selector. Now, what is the use of this table selector agent? Is to select a few tables which it thinks that the answer could be. So let's say the agent decides that as per the user query, my answer should be somewhere in table B, G, and P. Let's say it found 3 tables, or it thought of 3 tables which could hold the potential solution to the user's query. Then what we can do is we take B, G, and P. Now, since we have only 3 tables, we take B, G, and P, get out their schema. So in step 3, what we can do is get the schema of each of these tables and put it in a prompt. So we get this schema, put it in a prompt template. So let's say the prompt template is this, and the initial we have the system prompt: you are an excellent chatbot, answering questions, relevant questions, act like a good chatbot. So this is the system prompt. The user query is this, and I want you to reply with the response as per this tables. Okay, so we put the 3 tables schema here. So this is the entire prompt, and we send this prompt to LLM number 2, and we get the output. Okay, now what I missed here is that this agent will use LLM, so I'm calling that LLM 1. So it will use the LLM 1, get those 3 tables, get the schema from these 3 tables, put the schema in a prompt structure, and send it to LLM 2 and get the output. So how is that? In summary, if I start from the beginning, we have the user which would like to query. So let's say I prepare a user interface here and UI here. It sends a query here. The user sends a query. Now based on that query, we have the agent, table agent. This sends this message, pulls from the stored JSON file of the table description and the table names. It pulls out the appropriate JSON files and give me the output as the number of tables. Okay, 3 tables, for example, 3 tables here. Now we extract the schema of these 3 tables and send this to the LLM 2, and we have the prompt as well. So prompt input also we put in here. Then we get the output, and when we say output, we just get the SQL query, not the output per se, but the SQL query only. And then what you can do is send that SQL query to the database that we have and get the results. Okay, get the output of the database. If these steps fail, then we can, however, communicate this to the LLM, and LLM would give a new SQL query which we can send to the SQL database and then get the results. So this could be a loop, an agent. So I'm calling this agent 2, and the agent 2, and the first agent is a table selector. So the first agent is a table selector. The second agent holds the entire hard work of making the SQL query, sending into the query and checking if the query was executed successfully and getting back the result. Now after the result is gotten back, we can have an LLM 3. The purpose of that is to get this query and get this result and try to understand if it is a valid response. Can you consider the results that you get from the LLM 2 if it is valid or not? So if it is not valid, it can send a message back to agent 2. Now once it is valid, we can move ahead with other display. For example, a window where you can display the graphs, you can display the different options. But what I'm more interested is a black box here, and it's not a black box, a different box here, where there will be LLM 4, and once this entire sequence is started, what it can do is that you can ask follow-up questions. So the user can ask follow-up questions on the database, on the results and the response that it just got. So you can ask the follow-up questions. Now the LLM 4 should be smart enough as to understand if it is a follow-up question or is it the start of a new beginning. Okay, So this is the entire flow that I have in mind. I will start working on this since I already have an experience of working with one or two companies. So I will just try to make this and show you. In the meantime, if you have any comments, you can just put it in the comment section and I will be happy to integrate those options as well. But the one thing that I like to focus and the highlight what new that we are doing here is the selection of tables. So from the list of all the tables, we are selecting these tables. So this is where our innovation lies. The other part is the agent structure that we have already seen. This is also sort of an agent, but you can see how multiple LLMs are working together. Now for creating this, the tech stack that you're going to need is an agentic framework for the first option. But there are a lot many options in the space of agentic framework. We have to select one and move forward. So it's no use, finding the best framework. We can just take anyone and move forward. If it fits our goals, then well and good. So in the LLMs, what are the LLMs that you're going to use? So we can use different LLMs, try and find out the best LLM that you can use. Where are we going to host it? Can we host it somewhere? Yes, we can definitely host it. And can we make a subscription plan for this? The subscription plan could be this, that we can sell this as a service, and the companies, the users will come in and give the put in the database details. Okay, put in the database details, and once we have access to the database, we can see the number of tables there. We can make a description of of all the tables, and then we can construct that first part of the agent. Once that first part of the agent is done, the other is it's automated, because all the pulling of after the table names is received, the pulling of the schema and construction of this is all automated. But the first initial thing for every subscription that we get is to find the number of tables, log into the database, find the number of tables, I'll get a good description, because this is where the magic lies. Since LLM, likes a large language, since LLM likes a text description, we can very well put a text description here. Now, if the number of tables are huge, this is where we can improve. If the number of tables are huge in this step, we can definitely implement a RAG, but we would ask the LLM to output only the names of the tables. Okay, the output parser, you can use output parser and get the names of the tables only. We don't want anything else but just the name of the tables. So this is what I have been thinking, and this is what I would like to implement. I will start with this implementation, but if you have any comments, questions or suggestions, please feel free to put it in the comment section. If you like this video, please like this video and subscribe to my channel. If you want to support me, please support on Patreon for the efforts that I'm putting for you. Watch out the next video, and thank you. Have a nice day. Adios.